You know the sheer panic of, like, staring at a blank TV screen, frantically clicking the remote, wondering if the game console is on HDMI 1 or HDMI 2?
Oh yeah, we've all been there. It's the worst.
Right. Now imagine that exact panic, but multiplied by 160 screens, like during a live rocket launch.
That is a terrifying thought.
It really is. Today's deep dive takes us straight into the hidden, high-tech world of professional audio and video infrastructure. We are using a massive product catalog from HDTV Supply as our source map to uncover exactly how these massive video networks are wired and, well, controlled behind the scenes.
It's a totally invisible world to most of us, honestly. When you see a venue with dozens of perfectly synced screens, you are looking at some incredibly complex engineering. I mean, we tend to think of video cables as those stiff 3-foot cords tangled behind our TV stands.
Yeah, the ones that are always impossible to untangle.
Exactly. But at an industrial scale, the physical backbone has to completely abandon standard copper wire. Which brings us to the cables mentioned in our sources, specifically the DVIGear DVI-2850-AOC.
Wait, that's the DisplayPort 1.4 active optical cable, right?
That's the one. And what immediately stands out is the distance. I mean, it can transmit high-resolution video over 50 meters.
Okay, 50 meters is huge. But wait, if you're converting an electrical signal into light pulses, firing it down 50 meters of fiber optics, and then translating it back to electricity at the screen, doesn't that translation process introduce massive lag?
It sounds like it would, yeah.
Right, because if this is for a command center, wouldn't a split-second delay just be a total deal breaker?
It's a really valid concern, but that is the genius of active optical cables. The conversion microchips are actually built directly into the connectors at either end, so the data travels literally at the speed of light.
Wow, built right into the connector.
Yeah, exactly. Because, standard copper video cables lose signal integrity over long distances. The electrical signal just degrades. But fiber optics give you this high-speed fire hose for pixels, pushing massive bandwidth without dropping quality, or introducing noticeable latency for that matter.
Okay, so we've solved the distance problem with light pulses. But how do you prevent a massive traffic jam when you've got dozens of these light-speed fire hoses hitting the central hub at the exact same millisecond?
That is where the brains of the operation come in.
Right. The catalog mentions these industrial routers called Wolfpack modular matrix switchers. And the source says these can handle up to 160 by 160 TVs, which is just insane.
It is. And to understand how they manage that traffic, we have to look at the math. A standard HDMI splitter at home just takes one signal and crudely copies it to multiple screens.
Like you're splitting a pipe in two.
Right. But a true matrix switcher operates on an entirely different level. It creates a dynamic mathematical grid.
So it's not just a traffic cop directing cars, it's more like a magical intersection, where a car from 160 different incoming roads can instantly teleport to any of 160 different destination lanes without ever colliding.
That's a great way to put it. It creates millions of simultaneous dedicated pathways that can be severed and reconnected in milliseconds.
Without dropping a single frame of video.
Without dropping a single frame. Yeah. Any input can go to any output instantly.
But who is actually driving that intersection? Because, I mean, you can't have a bartender running complex routing algorithms on a Saturday night.
Definitely not. That is where the controlled ecosystems come in. The catalog outlines tablet systems called Wolfpads, free Windows 11 PC software, and even direct integrations with the DirecTV app.
So it just simplifies everything.
Totally. It takes the staggering mathematical chaos of a 160 by 160 grid and turns it into a simple drag-and-drop interface. And it handles the complex visual layouts, too, like PIP and POP.
Okay, I know PIP is picture-in-picture, like a small floating box over the main screen. But what does POP actually look like?
So, POP stands for picture outside picture. Instead of overlapping and covering up part of the game, POP dynamically scales multiple video feeds side by side on the same screen so nothing is obscured.
Oh, that's really smart.
Yeah, and the software can also take a single 4K image and stretch it flawlessly across a massive video wall made of dozens of individual TVs.
Which makes total sense for a massive sports bar. But looking at the purchasing channels in this catalog, the stakes go way beyond Sunday football.
Oh, absolutely.
Yeah, because I'm seeing federal GSA schedules, TAA-approved products, and NASA's CDEV program. Let's decode some of this. What does all that actually mean?
Well, TAA compliance means these components meet strict U.S. government manufacturing and security standards.
Okay.
And that certification is exactly why NASA can purchase them through CEVP, which is a specific federal procurement program for mission-critical IT and AV tech.
Wow, so it's literally rocket science.
Basically. When you need flawless, instantaneous video routing across hundreds of displays to monitor a rocket launch or coordinate a federal disaster response, you rely on the exact same principles and often the exact same hardware that routes the hockey game over a bar.
That completely changes how you look at a wall of TVs. I mean,
Yeah.
we've zoomed out from a single 50-meter optical cable to massive 160-screen AV matrix switchers that power everything from neighborhood bars to NASA
It
programs.
really reveals the hidden architecture all around us.
Absolutely. So, we want to leave you with a final question to ponder. The next time you stare up at a flawless multi-screen video wall, think about the immense invisible digital plumbing routing millions of pixels. In a highly interconnected 160-screen matrix, how catastrophic would the visual blackout be if just one central node failed?